Hi there and welcome students. We're looking at quadratic equations just a little bit more. This one is factorable. You could factor this one into x, a minus minus, and a 1 and a 1. Or in other words, I could have written this as x minus 1, quantity squared equals 0, and x equals 1. So there's only one answer, but that's because this crazy thing is written twice. What we say is that x equal 1 has a multiplicity of 2 because it was to the power of 2. Had it have been to the power of 3, it would have a multiplicity of 3. Normally we solve these problems and we have something like x squared, we'll say plus 5x plus 6 equals 0. And normally we have something that looks like x plus 2, x plus 3. So we say that x is equal to negative 2 and x equals negative 3. Well, in each of these cases, we say that each one of these has a multiplicity of 1 because there's an understood 1 on those powers. So just adding a little something when we're solving it to say that this 0 here on this 1 is listed twice, and we call that multiplicity. We say that each of these has a multiplicity of 1 because each of those zeros is just listed once. On some of these problems, they're going to give you the answers and ask you to find the quadratic that works for this, or whatever the polynomial might be. So let's look at this. They tell me that the answers are 2 and negative 3. Those are the solutions. So that means I know that we had to have started with x minus 2, because that would be a solution, and x plus 3. That would be a solution, because if I plugged either one of those two numbers in, I would get that 0. If I plugged in a 2, I would get 0. If I plugged in a negative 3, I would get 0. Then working through this, multiplying it back out, I would get x squared. That's plus 3 minus 2, so that'd be plus x minus 6 equals 0. So this would be your equation that you would be looking for. They could give you something like, let's say they gave you x equals 2, and they said with a multiplicity of 2, all that would mean is x minus 2 is your answer, and you just say, multiplicity 2 means there was a square on that guy. If they would have said a multiplicity of 3, I would put a 3 up there, and then I'd have to multiply that out too. And so multiplying this out, x minus 2 times x minus 2, to figure out what that polynomial would look like, that would be minus 2x would be minus 4x plus 4 equals 0. There's what they're going to be looking for. And they're going to give you several of these. So I'll show you a few more, maybe with a square root and with a with an I in there. Now, one thing I know about these square roots is that they always occur in pairs. There's going to be a plus guy and there's going to be a minus guy. So I know right off the bat, if they tell me that 1 plus the square root of 3 was an answer or a root, I would also know that 1 minus the square root of 3 would also be a root, because these things occur in pairs. Same way with the imaginary numbers, just because the quadratic formula was used to get those, and I know that that had to have happened. That's just kind of a side note. I'm not sure if they might have a question that related to that, but we'll look at it. So you can plug in here. You can say, okay, this would be x minus the square root of 7 and x plus the square root of 7 would work. This plus square root of 7 would make that 0, minus would make that 0. They're going to want you to multiply this out, so that's going to be x squared. You're going to get a plus square root of 7x minus square root of 7x, so that's going to drop. And then you're going to get minus the square root of 49, which is a 7. And this is going to be the equation that they're looking for. All right, let's look at this guy. This means that minus 4i was an answer, and this one would be for the negative 4i, so let's multiply that out. It's going to be x squared minus, be the plus 4ix minus 4ix. Then I get minus 16i squared equals 0. Of course, I squared, if we remember from our imaginary numbers, is a negative 1. Makes me happy. So I then get x squared plus 16 equals 0. And that's what they're looking for. All right, I'm going to look at this one because I want to go forwards with this one for just a little bit. Because sometimes when we have those coefficients in front, it really makes things difficult, especially when we try to factor. So when I factor something like this and I have a 1 and a 15 or a 3 and a 5, and I don't know which one will work, 8, it could be a 1 and an 8, a 2 and a 4. I don't know which pair will work. I know I've got to try to make a 2 with this, so I do this guess and check method. I don't think the 15 is going to work because I think it's too big, so I'm going to play with these guys and these guys for a minute. So I'm going to try a 3x and a 5x. I know that I've got to have a 2 there in the middle, so I kind of want to, I think if I look at 3 and 4, that's going to make a 12, and then the 5 and 2 are going to make a 10. So I know I can get a 2 that way, but I need the big one to be negative, so I'm going to make it look like this. So there's how I would factor that one. Let me make sure it's right. See, that's 15x squared minus 12x plus 10 minus 8. Oh yeah, that one works. So that's good. It all worked out nicely. So what are the answers here? This is 3x plus 2 equals 0 and 5x minus 4 equals 0. So 3x equals a negative 2, or x equals negative 2/3. So that's an answer. X equals, oops, move the 4 up, 5x equals 4, so x equals 4/5. And that's an answer. So what if they start you off with, they say, hey, you have two solutions, x equals negative 2/3, and you have the solution x equals 4/5. Well, you can play with it like this. And you can multiply your fractions and add it, and that will be a fine answer. It'll just have some fractions in it. If you don't want to deal with the fractions, just kind of work backwards from here and say, okay, well, if the answer was negative 2/3, I know I had to have a plus there. I know it was divided by 3, so that's got to be a 3x there, and then the 2 had to have been here. So, and look, that is what would have happened. Same thing here. I know it was divided by the 5, so that has to be 5x. That's a positive, so it's going to be a minus, and then a 4. Now, I don't care which way you work it. You're going to have to multiply it out. The answers will look different, but they will be equivalent. So either way, I believe XYZ will accept any of that. All right, let's say they give you something that looks like this and tell you to find the equation. So you'd say, okay, x minus 3, so x plus 3, and it has a multiplicity of 1, so you just have a 1 right there. And then x minus 2 is your other guy. That would make that 2 a solution. This has a multiplicity of 2, so you would have to work it that way. You'd have to put a 2 on it. So now what you have to do is take this x plus 3, this x minus 2, and this x minus 2, and you have to multiply the whole thing out. So you can do it in any order. I'll just take those two because they came first. Multiplying that out would be x squared minus 2x plus 3 is plus x minus 6. Then I have to multiply it by this x minus 2, and yes, you do. You have to multiply that. So I'm going to take each thing's inside of here, multiply it by each of those. So it's going to be x squared times x, that's x cubed, minus 2x squared, plus x squared, x times that is minus 2x, minus 6x, plus 12. You just have to keep track of it, and it's just each one of these times each one of those. So you have to do the x times both of those and the 6 times both of those. And then collect your like terms. So I'll move this up just a little bit. X cubed looks minus x squared minus 8x plus 12. And there she is. All right, if you need any more help with this, you be sure and send me an email. And good luck to you, and have a wonderful day.